Here we're looking at a typical AP style fundamental theorem of calculus problem. In this case, we have a particle moving along a coordinate axis. Its position at a time is given by the function s. So s is a position function defined as the definite integral of f. F is the graph to the right. Part A says, what is the particle's position at a time of 0? Since s represents position, we're trying to identify what is s of 0. Well, s being defined as the definite integral, we need to evaluate the definite integral from 0 to 0 of f of x dx. We know that any definite integral going from 0 to 0, or any constant to the same constant, is equal to 0. Part B, what is the particle's position at a time of 3? Similar process. S is a position function. We want the position at 3 seconds. Position is defined as the definite integral from 0 to 3 f of x dx. Well, to determine the definite integral from 0 to 3, refer to function f. Here's function f from 0 to 3. We'll use the concept of area to determine the area between the curve and the x-axis. Area below the x-axis shows the total distance traveled to the left because the area is negative. The area of this triangle is 2. At a time of 2, the particle changes direction and moves to the right. This is an area of 1/2. Position at a time of 3 then, -2 plus 1/2 is -1.5. C, what is the particle's velocity at a time of 4? This is a direct application of fundamental theorem of calculus. Velocity is the derivative of position. The derivative of the definite integral by fundamental theorem of calculus simplifies to f. We want to evaluate then what is f of 4, referring to the graph again and identifying where time is 4 puts us at this point. So based on the graph, the particle's velocity must be 3. Part D, approximately when is the acceleration 0? Acceleration is known as the derivative of velocity. The second derivative of position is velocity, or is acceleration, which is the derivative then of f. At what time then is f prime equal to 0? So looking at the graph, we are basically looking for where f prime is 0, or where there be a horizontal tangent. At what time do we have a horizontal tangent of f? It looks like we're approximately there at 4. In part E, at what time during the first 7 seconds does s have its smallest value? Well, smallest value, or minimum, we'll determine that by figuring out when does s prime equal 0, or when does f of t equal 0. From looking at the graph, the only place or only time when the velocity is 0 is at a time of 2. Since we know then the function goes from decreasing, where s prime is negative, here s prime is positive, we go from f prime being negative to positive, decreasing to increasing. Therefore, we know that that has to be a minimum at a time of 2.